Hey class, how y'all doing? All right, this is the first section in Unit 9. This would have been the next book we covered in class, but except we're not at school and they're sitting on a shelf in the classroom. It's exponential functions. And we talked a little bit about exponential functions when we talked about transformations and we were doing some prep for the benchmark. We also talked about exponential functions. They are, I'm just going to read what it says here. An exponential function is a function, here I'm reading, of the form y equals a times b to the x, where a cannot be 0, b is bigger than 0, larger than 0, greater than 0, and b cannot be equal to 1. These are just conditions, and we've encountered these before. Like when we had something in the denominator, we would have to say where like a is not equal to 0, because if a was 0, you can't have 1 of nothing. Same thing here. A cannot be 0, because if a is 0, a times b to the x is 0. Y is equal to 0. That's just the x-axis. B needs to be greater than 0, and B can't be equal to 1. Same reason A can't be equal to 0, B can't be equal to 1, because if B was equal to 1, this is interesting. Come over here. I'm trying to make this video faster. I did it once before and it came out way too long. So, all right. So if B is equal to 1, I'll have A times 1 to the x power. Okay, let's say A is equal to 2. I have 1 to the 1 power. 1 to the 1 power is 1. 1 times 2 is 2. Okay, let's say now I'm going to make x equal to 2. 1 times 1, 1. 1 times 2 is 2. So kind of like the same thing if a is equal to 0, if b is equal to 1, we're just going to have some sort of horizontal line. Y will only be that number, not the exponential, not the curve. So we're going to do 4 different explorations. Activity 1 here, activity 2, activity 3, activity 4. They're not going to take too long as I don't talk too much. What you're going to notice here on your copy in Google Classroom, it says type here. This is a text box. I want you to type your answers here. I want you to type your observations here. You're going to be handing a copy of this document into me through Google Classroom instead of a Google form this time. And you're going to put your answers right there. You can type in this document. This is your document. All right. We read through there. You have explored the graph of linear functions. We've also explored the graph of quadratic functions. That was y equals x squared. Those were our parabolas. And remember, we put things in front. Remember that Super Mario activity? Several things we did. If you put a number in front, something happened. If you put something on the end, something happened. The same is true for exponential functions. As we change things, add things, it's going to move, shift, get wider, skinnier, steeper. It's going to do all kinds of stuff to it. And that's what these 4 explorations are going to show us. So our first one is, why isn't it? There we go. So for the first one, we're going to put into Desmos, and we're going to explore what happens to B when we change B and B is greater than 1. So with B greater than 1 means B is not between 0 and 1, which are your fractions. All right, so let's come over here to Desmos. We have y equals 2 to the x power, y equals 3 to the x power, y equals 6 to the x power. So our number got bigger. It went from 2 to 3 to 6. What happens when we do that? Ta-da! So I would love for you guys to have Desmos open or pause the video, open up Desmos and do this on your own so you can do your own exploration. So right here, I have my 3 functions. Let's graph y equals 2 to the x. There we go. It is a curve. It is increasing as x gets larger. So over here, it's way down, almost equal to 0. And trust me, it never crosses the x-axis. It is never negative. We'll talk about that in a minute, about the range. Remember, the range is your y value, your up and down. Here we go. It crosses the y-axis at 1. That is our y-intercept. There is no x-intercept, by the way, and it increases. As x gets larger, our graph is going up. It is increasing. All right, here's our second one. Y equals 3x. What do you notice? It's crossing through 1 again. Our y-intercept is the same, so we have the same y-intercept. So when x is equal to 0, y is 1. As x approaches infinity, as x gets bigger, y is also getting bigger. So as x gets bigger in the positive direction, y is getting bigger in the positive direction. Which one is doing it faster? The red line is doing it faster. It is going up much quicker. Do you think that's going to be true for when we change it to 6? Yep. What do we notice? We still have a y-intercept of 1. When x is 0, y is 1. As x gets bigger in the positive direction, y also gets bigger in the positive direction. Which one's doing it faster? Pause the video. I would love for you to pause the video right now and go back to this document and type in your observations. My observations are, well, I pretty much told them to you already, as x gets bigger, it increases, and the y direction as well. Y is also getting bigger. But the main takeaway is the blue one, where y is equal to 6, is increasing faster. It's like, think of a linear function. Think of slope. Which one of these two is increasing faster? The second one I drew was increasing faster. The slope of that one is larger. That one's increasing even faster. So as b changes, as b gets larger, it gets steeper. That would be my observation that I will type in this little box here. Hopefully you paused the video like I asked you to, and you typed in the box. So let me give you an example. You can type over the type here as x increases, y increases faster when b is larger. You can also say maybe the bigger the b, the steeper. These are all acceptable answers, and whatever you type or typed already probably is an acceptable answer. Good job. High five. Woohoo! All right, let's go on to the next one. All right, now activity 2. We're going to look at the effect on B on the graph is different when B is between 0 and 1. So B is still positive. Remember we said B was going to always be positive? So B is now between 0 and 1. It is not equal to 0 and it is not equal to 1. It is between 0 and 1. Well, examples of numbers between 0 and 1, right here. 1/2, 1/3, 1/6. Oh, I want to go back and talk about something real quick. You'll notice in these directions when you read them, it says to zoom. This was assuming we were doing it in the classroom and we have the calculators out, and there's a zoom feature on the calculators. So you're going to pretty much ignore that. Zooming in twice on a point, you can still zoom. Desmos has a zoom function. It's just this plus key over here. So you can zoom in, zoom in, zoom in, see what's happening. I find it interesting over here when x is negative that it's flipped. And it's in the opposite order. It's going up faster. The black line's increasing faster over here, and then the blue line surpasses it. All right, that's a discussion for another day. I'm trying to not make this video be too long. All right, so now we're going to look at what happens when B is between the numbers 0 and 1. I graph these two, back to here. I graphed These three are ready for us. Here's your text box. So you're going to pause the video again and type in this text box. Let me clear this off. Boop. All right. Here we go. Oh, let me ungraph these. Bye, bye, bye. There's y equals to 1/2 x. What do you notice? It's still crossing at what? It's still crossing at 1, isn't it? This time, though, look, it's approaching the x-axis over on the right side where x is positive, and it's going up and increasing on the other side where x is negative. Let's do the next one. So that was 1/2. Ah, that's the 1/3. What's an observation? Pause the video, think for a minute. What's an observation you can make? I notice that they still are both crossing the y-axis at 1. So when x is equal to 0, y is 1 for both of those graphs. Then this one is also increasing over on the left where the x's are negative. Which one is increasing faster this time, though? The 1/3. Which number, 1/2 or 1/3, is the larger number? The 1/2 is the larger number. I always like to think of pizzas. Half a pizza, a third of the pizza. Which is bigger? Half is bigger. So this time the larger number, as we get more negative, the smaller number is increasing faster than the larger number. Let's see if it holds true. So we have 2. Let's see for our third one if the pattern holds true. Bam! Oh my gosh, it did the same thing, didn't it? Still has a y-intercept of 1, and this number is 1/6. 1/6. Now you only get 1/6 of the pizza. So each one of these pizza slices are cut in half. So each of your thirds are now a half, and you're only getting that much of the pizza. So it's even smaller. So pause the video again, go back to your document. What have you noticed? Type it in this box here. Type it in this type here box. My observations are, this time, the smaller the number, the steeper the graph. So, but it's increasing in the opposite directions this time as x approaches negative infinity. So as x gets more negative, y gets more positive, y gets larger. And that's what minus negative, and that means you're going more negative. Infinity, I'm going off forever in the negative direction. Y is going to be shooting off forever in the positive direction. And the smaller number is doing it faster this time. Good job. If that is close to what you wrote, something what you wrote, awesome. If you just wrote anything down, can we have a high five? Very good. All right, let's get rid of these bad boys. Bye, guys. Number 3. I didn't type anything this time because I want to see your thoughts. I want your thoughts. You can always pause this video and go back and listen to my thoughts, but I want to see your thoughts. You type something here in this box for me to read when you submit this document. Number 3. This time we're not worrying about B. B is staying the same. B is going to be 2 in these examples. See right here? 2, 2, 2. And A is going to change. A is going to be greater than 0. That means A is positive. A is a positive number. So what's going to happen as we change A this time? I want you to have Desmos open. Go into Desmos. Pause your video real quick. Pause the video. Put them in Desmos. I have them in Desmos already. Here they are. y equals 2x, y equals 3 times 2x, there's your a, y equals 1/6 times 2x. You're saying, Miss Jones, but there's no a on the first one. Well, there is. There's a 1. 1 times 2x. I didn't need to write it because when you multiply by 1, nothing changes. There we go. And that was the same as the one from the first one, wasn't it? My y-intercept, when x is 0, y is 1. That's your y-intercept. Increasing, same thing, as x increases, goes off in the positive direction. That's supposed to be an infinity. Y is also increasing, going off in the positive direction, shooting up. It's hovering, hanging out down here, hanging out, hugging that x-axis, hugging the x-axis slowly, and then pew, shoots off into outer space. All right, let's load up the second one. Ooh, wait a second. Where'd it go? Does it have the same y-intercept this time? Where did it go? Oh, it's crossing up here, isn't it? Oh. I will get used to Screencastify. About the time we get to go back to school, Miss Jones will be an expert at Screencastify. All right, so this one was crossing at 1. This one is crossing at 3. So this time, the y-intercept is 3. So can you make an observation about the a? When a went from 1 to 3, what happened? Okay, I hope you paused the video and thought about it for a second. Now the last one. Oh, that down there. Now remember, this one, so this one is a was equal to 1. This one, a was equal to 3. It got bigger. This one, a was equal to 1/6. It got smaller. But what do you notice? The y-intercept is 1/6. So that's definitely something you can type in your observations. Go back to this document. Type here. Type something about that. Type something about the effect it had on your y-intercept. That would be awesome. Also, maybe talk about steepness again. I would love for you to talk about steepness. Which one is increasing more rapidly? So look at this one. It's going up. Choo! Going up, kind of slower going up, and then choo! This one, it is in no hurry to go up, no hurry to go up. I'm going to take my time, and then kind of goes up. So play around. Sorry. And play around with it and see what you notice. Make some observations. Now, there's a key vocabulary word we haven't really talked about yet. It's over there on the notes, and it's called the asymptote. I know we talked about this. I totally probably did not spell that correctly. Let's see. Oh my goodness. ASYMPTOTE. ASYMPTOTE. Oh, I spelled it right. Yay! Your asymptote is the x-axis. This, you're going to trust me on this. It's hard to see. It looks like, and Desmos will tell you that it is at 0, but it's not. It is close to 0. It's super duper close to 0. Like right here, look, it's 0.021. It just gets more and more decimal. And Desmos finally just like gives up and says, hey, it's 0, but it's not. It's 0.0000 something. Exponentials approach 0. Y is going to get super close to 0, but it's never going to hit there. It's going to get very close, but never going to hit it. This is your asymptote. Your asymptote is a line that something approaches, but never quite gets to. And then we can think about domain and range. So far, we talked about our x and y can be in both directions. But what about our range? What do you think? Pause and think about that. Your range. Is this function ever going to exist down here at the bottom? Is it ever going to be negative? Never. So your range for these exponentials is y is greater than 0. Not equal to, greater than. Now later on, you might add or subtract something on the end. Remember with quadratics, that shifted it. So your range will go down below 0, but it's going to start at your asymptote. It starts at this line. All right, I think I talked enough, and you can have some really good something or other to type into that box. Once again, ignore this Zoom. This talks about the domain. The domain for each function is all real numbers. It's that way for all of these. And the range is all positive real numbers. That's your y is greater than 0. The functions are increasing over the entire domain. The graphs do not display any line of symmetry. All right, last one. This time, we are going to play with a, but we're going to make a negative. Interesting. What do you think is going to happen when we make a negative? Let me say bye to these. Bam, bam, bam. Think about it real quick. Pause the video. Think. What's going to happen when a is negative? I want you to think, what happens when a is negative on a quadratic? What happens when a is negative on a linear? What did it do? Think about it. We did tons of those. We did so many of those. Pause. Welcome back, because I know y'all paused. Bam. What do you notice? Is it increasing, going up positive forever and ever and ever? I'm going to open this bad boy back up here. Oops. That's y equals positive 2x. That's y equals negative 2 to the x power, not 2x. 2 to the x power. What do you notice? Now it's where? It flipped over the x-axis. It reflected over the x-axis. All right, so now we're down here. And you notice we still have an asymptote. It's not crossing the x-axis. It's living down below it now. It's not living up here and y is greater than 0. It's living down here and y is less than 0. Ooh. So if you notice, we went from negative 2 to negative 3. So a is negative 3 now. Look what when a was positive 3. What do you notice? Same thing. It's just your y-intercept changed. Your y-intercept went from positive 3 to negative 3. But we're supposed to be comparing these 3 to each other. Last one. All right, so that negative reflected it over the x-axis, and comparing these to each other, the y-intercepts all changed. Which one is the steepest? The negative 3 is still the steepest when you think about it. It's just steeper in the negative direction. It's like a negative slope, steeper negative slope. There's your next one. There's your last one. So it's pretty much the same as this one, as the number 3 we did. So your observations from number 3 just flipped over on the bottom. It's now negative. So can we say as x increases in the positive direction, y is going to be decreasing, going down. The function is decreasing. Our range is less than 0. Our domain is still all x's. This thing, oh my gosh, we could zoom out forever. Look, I mean, that bad boy is existing off forever in both directions, in the x, negative and positive directions. But it does not live over here. It'll never exist over here. All right, so I want you guys to come back over here. Type your observations in this box. What did you notice? What did you see? I'm grading this. It's not a Google form. I'm going to read these tomorrow, or depending what day you read this, watch this video. I'm going to be reading these on Friday. and reading your answers. So spelling, do your best on your spelling, but don't freak out about that. Type your thoughts. I want to read your thoughts, your observations. Go and put some more in Desmos. Now, this page here out of your book, as you recognize, normally would have been your Google form. I'm not going to do a Google form for this one. This one, I'm going to read your boxes. I made them these pretty little purple text boxes. You come in here and you type in your answers. How does B affect the graph of y equals a times b to the x power when b is greater than 1 and when b is between 0 and 1? If you go back and look at your example number 1 and your example number 2, you should be able to type a pretty good answer. Okay? Give examples. Number 2, how does A affect the graph of y equals a times b to the x when a is greater than 0 and when a is less than 0? Give examples. That was, which two examples, guys? A is less than 0, so you're going to compare number 4. Oops. Ah! Sorry. Go back there. You're going to compare number 4 to A is less than 0. That's negative. That's number 4 when A is greater than 0. Number 4 to number 3. So look at the ones you graphed in number 4, the ones you graphed in number 3. Make some observations. Type your answer in this little text box. I think I gave you a little bit of a hint, like something to do with reflected. Reflected. Here's my x-axis. Oh, what can I reflect? Oh, I'm going to reflect this ice cream cone. My ice cream cone is up here above the x-axis. Put a negative a in front of it. It went underneath the x-axis. So think about that. That would be something good to type in this box. Go back and rewind the video. Listen to my rambling. I probably gave you the answer to that question. Finally, analyze relationships. Make a conjecture, that's like a prediction, about the relationship of the graph y equals 3x and y equals 1/3 x. So this time 3x, so b was 3. So that was number 1 and number 2. So you're comparing number 1 and number 2 this time. Oh my goodness, I clicked the wrong thing. Still clicked the wrong thing. All right, you are comparing number 1 and number 2. And they gave you specific numbers. Look at for when y is equal to 3x and y is equal to 1/3 x. So this one is super general. Use any example you want that fits these criteria. We're super general. Use these criteria. And on the last one, you're specifically comparing y equals 3 to the x power and y equals 1/3 to the x power. What do you notice? Not sure how long this video has been so far. Sorry if it's too long. Let me go and look real quick. So y is equal to 1/3 x. Y is equal to 3x. Oh, okay. What do you notice? There's a lot of observations that you can make about this. There are some screaming at me right now. But I want to see your thoughts. Type it in there. You're going to submit these through Google Classroom by Thursday at 11:59 p.m. for me to give you feedback on Friday. I will give feedback on Fridays and type, yay, good job. Ooh, maybe you need some work. And if you get it done earlier, you'll get your feedback back earlier probably. All right, thank you for watching the video. Please pause where I said pause and think, rewind and rewatch this. I talked a little fast because I really didn't want the video to be really long. So sorry, give me some feedback on the video. Let me know what I can do different, what I can do better for next time. This is new for me. I teach online all the time. Y'all know that. I talk about my students all the time. This is my classroom. If you notice, I have a few things hidden in the classroom. Tell me if you notice who's hidden in the classroom today. There's 2 people visiting us and a couple not people, mammals visiting us today. That's a game I play with my students in China. I have something in the classroom and they have to find it. Not like the stuffed animals and stuff, but I put a little thing in there. If you go back and watch the Khan Academy Help video, I had somebody hanging out in the classroom in that one too. Have a great day. See you later. Bye.